Hey guys, welcome to another WISP video. Today we're going to talk about scientific notation. If you look on the screen, scientific notation is the primary way that a lot of math and science come together. So here are some examples how we use scientific notation. Just how hot is the sun at its core? Well, the answer is it is 1,550,000 degrees Celsius. Another example, how far is it from Earth? The answer is 93,000 miles from the sun. So the Earth from the sun is 93,000 miles. Those are really big numbers. We use scientific notation for very big or very small numbers. So standard form is what I said earlier. So when I said that the Earth is 93 million miles from the sun, that's standard form because you can see it all written out. Scientific notation is kind of like the shortcut of writing really big numbers or really small numbers quickly. How scientific notation works is it's pretty cool how it works. So if you look on the screen here, um, we'll just go over some basic power of 10. What I know is that when I have 1 times 10, I have 10. What I know is when I have 1 times 100, I have 100. And yes, 1 times 1,000 is 1,000. And 1 times 10,000 is 10,000. Why do we need to know this? Because really, if you come down here, you can tell that 10 to the 1 power is 10, 10 to the second power is 100, 10 to the third power is 1,000. So if I had a number and I told you I wanted to multiply 2 by 1,000, that could be written as 2 times 10, the base 10, to the, 1,000. It's going to have 3 decimal places, so 10 to the third power. Both of these are equivalent. They're one of the same. Kind of confusing right now, but just have that in mind. The scientific notation has multiplied by a base of 10. All right, so let's jump right in. Scientific notation. Please write 7 and 66 hundredths times 10 to the 6th power kilometers squared. So this is the area of Australia in standard form. So we need to write this in standard form. So standard form in scientific notation really means, hey, write it out long ways. So you look right here, I have 7.667 and 66 hundredths times 10 to the 6th power. So earlier when I go back here, when I multiply 1 by 10, I just move the decimal once to the right once, because when we move the decimal to the right, numbers get bigger. So when I move 1 by 100, 100 has 2 decimal places. So it's really 1, 2. I get 2 decimal places, put a decimal. When I multiply 1 by 1,000, here's my decimal place, 1, 2, 3. Fill in zeros, and so forth and so forth. So when you have a positive exponents with a base of 10, that tells you need to move the decimal that many times to the right. So in this case, I need to move the decimal 6 times to the right. So write 7.66 and write your decimal, move your decimal 6. There's 1, 2, 3, 4, 5, 6, and put my decimal right there. So my final answer is 7660000, and I know that that is going to be 7,660,000, and that's standard form, the size of Australia, a kilometer squared. Okay, so that's how you write standard form from scientific notation. All scientific notation is moving the decimal. Here's another one. Express 3,476,000 meters, the moon's diameter, in scientific notation. So this time, I have a really big number in the millions. And I need to write this in scientific notation. Well, where's the decimal place in this really big number? Well, it's at the end. And here's the tricky part. Scientific notation, in the ones place, we can only have the ones place, which means that in the number between the decimal and the whole number, it has to be between 0 and 9. What I mean by that is you can go move the decimal to the left, 1, 2, 3, 4, 5, 6. So I know that my numbers that I'm actually going to play with, I'm ignoring the 0, it's going to be 3.476 times 10, because we're all on the base of 10. Base of 10 means I can move the decimal right or left, and I just count. 1, 2, 3, 4, 5, 6, and put that superscript right there. And that is 3.476 times 10 to the 6th power. When I write that out in standard form, it should be the same. What I meant earlier by saying that the significant figure right here, the ones place, it has to be between 0 and basically 1 to 9. Okay, it can't be, because if I would go on and I get like something like 3.3476 times 10 to the 7th, that wouldn't work, because I need a number right here, and that number designate that, hey, that's the ones place. When I multiply by 10, I can move it. So you need to move it back, and basically just remember that I need to have one number between my decimal point. Okay, I need to have one number between in front of my decimal, and then followed by the other numbers neglecting the 0. So a quick way to check your work on this is using a TI-84. I don't have a TI emulator like I do at school on my personal laptop, so I'm in the process of getting that, but I'll try to show you guys. So it's 3.476 times 10 to the 6th power. Should look something like that, and when I hit enter, I should get the same number that they gave me, which I do. I get 3,476,000. Okay, so that's how you quickly check your work. You can write it shorthanded, you can write it standard form, and they are equivalent, they are the same. Alright? Alright, so let's talk about negative exponents. So, positive exponents, if you want to quickly look at it, positive exponents means something like earlier, 3.476 times 10 to the 6th power. We move the decimal to the right. Well, just like in math, the inverse of positive is negative, so what do you think, which way you think you're going to move the decimal with the negative exponents? It's going to be, we're going to move it to the left. Okay, so what that means is, negative exponents means I move my decimal to the left. But when I have really small numbers like this, it means I move my decimal 1, 2. So again, here it is expressed. That would be 123 10,000ths, right? 1, 2, and there's my 1, so it's going to be 1.23 times 10, and I'm using my decimal point. I move 1, 2, negative 2. What I meant by negative exponents is that when you check your work, times 10 to the negative 2, I need to move this is a negative exponent right here, so what I do is I move it to the left twice. 1, 2, put my decimal, and put a 0, and it should be the same. Again, you can quickly check your work. I have 1.23 or 1 and 23 hundredths times 10 to the negative 2nd power, and 1.23 times 10 to the negative 2nd power. And if you look quickly, remember to use the negative symbol and not the subtraction symbol. You'll get an error. Okay, so if you want to quickly pause the video and try this one by yourself, you can. If not, you can just follow along. So this one says write 2 5/10 times 10 to the negative 4th inch, the diameter of a cell, in standard form. So standard form means, hey, write it out longhand. So here I have 2 5/10 times 10 to the negative 4th. And this is a negative exponent, so that means I need to make the number smaller. You can think about it as a negative number means small, so the number that my final answer, if I write out in standard form, is going to be much smaller. So just write 2.5, move the decimal 4 times to the left, 1, 2, 3, 4, put the decimal, fill in with zeros. So my final answer in standard form is going to be 0.0025 inches. And that is standard form. You can rewrite this in scientific notation the same way by going reverse if you want. So something like this. You move it to the right. 1, 2, 3, 4. So it's going to be 2.5 times 10 to the negative 4th. Last one. Go ahead and try this by yourself again, and then you can hit play to check your work, or you can just do it with me right now. So starting at the decimal, remember scientific notation is all about the decimal and the power of 10. So I'm going to move 1, 2, 3, 4, 5, 6 to where the first number is in front of the decimal. So I get 3.5, and I count 1, 2, 3, 4, 5, 6. I moved it to the right 6 times, so that's going to be -6. That's going to be a really small number. Quickly check your work on your calculator if you want. You should get the same answer as they give you. And that's pretty much it on scientific notation. So let's talk about some common mistakes that I've seen in the past. So for example, in that last one, where I had 3.5 times 10 to the -6, a common mistake that young mathematicians that are in a hurry and very bright and understand it, they sometimes go like this. Are these two the same thing? It's going to be the question I'm going to ask you right now and in class. And the answer is no. This and this are not the same. This means I just moved the decimal. This means something completely different. Negative exponents without the power of 10 basically means, hey, you better put it over 1. So this is not scientific notation. This isn't scientific notation. Same thing with positive. If you have 3.5 times 10 to the third, sometimes students for some reason go 3.5 to the third power. Again, we know what 3.5 to the third power. This means 3 and 5 tenths times 3 and 5 tenths times 3 and 5 tenths, which is not going to give you the same answer as this. Okay, so be careful of that common mistake. Just know that scientific notation, we need to have something like 2.5 times, we need that 10, power of starting with 1, 2, 3, 4, depending on if the number is positive, if the number are a large number. If the number is really small, you know you need to use the negative exponents. So that's all I have for today. Rewind the video, pause it, practice again with the video. In the question comment, make sure you try to come up with some examples or any questions you have about this video, and we'll go over in class. Alright guys, thanks.